Hello, Honors Chemistry, and welcome to Chapter 5, 5.5 through 5.7, and this is our introduction to ionic compounds, the naming of ionic compounds. So, this is the diagram that I put in your guys' outlines because it makes sense to me. If you don't like it, feel free to create your own. Before we can name or write a formula for any kind of compound, first we have to know what kind of compound it is, right? So in order to know that something is an ionic compound, we have to look for, right, cation and anion, right? That's what it's got to be made of, is a cation and an anion, right? And that's going to tell us that it's ionic, right? More commonly, this is going to be because we have to know what that means, right? What is a cation and what's an anion? We'll be looking for a metal and a nonmetal, right? Or it could be a metal and a polyatomic ion. And sometimes it can be two polyatomic ions if one is a cation and one is an anion, right? So two polyatomic ions. So those are our three options, right? It can be one of those three things, and if it meets the criteria, then it's an ionic compound, right? Then we have to decide, is it a type 1 ionic or a type 2 ionic, right? Type 1s are ones with an invariant charge on the metal, right? Which, when we say that, right, that means nothing to you at this moment, but just pause, right? And type 2 means a variant charge on the metal. Okay, and so what that means is there are certain metals, right, that have a fixed charge. It will always be a specific value, right? And then there are a whole bunch of metals where the charge is not fixed, where the charge of the metal varies depending on what it's stuck to, right? And depending on the conditions in which the compound was made, right? And thankfully, there's a simple diagram from your book. I forget which figure it is, but it's in your book. And it tells you, right? So it tells you, right, that hydrogen, it tells you that your group 1 metals, and we'll go ahead and include francium there, right? Your group 2 metals, and we'll include radium there, right? Scandium, and then these three right here all have a fixed charge, right? Now, you'll note that these group 1 metals all have a +1 charge, right? And that goes back to what we talked about previously, right? Where all of everything in that group has one valence electron, and in a reaction, it will tend to lose that one valence electron, becoming a 1+ ion, right? Here, these have two valence electrons, and in a chemical reaction, it will tend to lose those two valence electrons, which means now it has a 2+ charge, right? Scandium, same principle, right? 3+, right? And these over here, right, you just have to memorize those, right? But it's pretty simple, right? 3, 2, 1. And again, you are welcome to mark these on your periodic table with some shading or symbolism, as long as you don't write any words on your periodic table. What that means is that everything else is a type 2, right? So these are going to be your group 1 and 2, right? And aluminum and zinc and silver, right? And that's it. Oh, and scandium. And that's your list of type 1 metals. So if it's not one of those, it's type 2. Yes? All the others. All right. Now, our type 1s and type 2s can be differentiated a little bit further, right, into binary or polyatomic ion, right? And if we think about the word binary, what does that mean? Right, it means two, right? It means that it's composed of two elements. Only two elements, right? And that's all it's made of. Whereas a polyatomic ion clearly, I feel like, contains a polyatomic ion, which means that when you look at the formula, it's going to have 3 or more elements, yes? Right? That's one of those things we're going to look for, right? Only two elements, right? This will have 3 or more elements, right? With like one exception, which you're going to memorize, and it's all good. We'll talk about it when we get there. All right. Next up, knowing our polyatomic ions. So first of all, actually we'll come back to this chart later. But here we have our common polyatomic ions, and this is a diagram from your book, table 5.3. Yeah. Yes, you do have to memorize them, right? You do need to know when I say acetate that means C2H3O2, right? So again, C2H3O2, that's the formula, right? As in there are 2 carbons, 3 hydrogens, and 2 oxygens, and there is a charge of -1. Yes, this whole ion has a charge of -1, right? Polyatomic ion, where poly means more than one atom that makes up an ion, yes? Or for carbonate, right? When I say carbonate, I mean CO3, and 2- is the charge, right? So this particle, this ion, has a charge of 2-, okay? And you do have to memorize them, but you'll notice that there is, for a lot of them, a naming system, right? So if we look at the difference here between carbonate and hydrogen carbonate, right? For hydrogen carbonate, all we did was add a hydrogen to the carbonate. And if we think about where hydrogen is on the periodic table, right, it's in group 1, which means that if it were to behave like an ion, what kind of charge would it have? Right, +1. So if I take a 2- and I added +1 to it, I would end up with a negative charge. Oh my gosh, right? If we look at, and that persists over here, right, where we have phosphate, and then we have hydrogen phosphate, where we go from, all we did was add a hydrogen out front, and we go from -3 to -2, right? Or for hydrogen, for sulfite versus hydrogen sulfite, yes? Okay, in terms of other naming systems in here, right, there's also the naming system of a group, right? So here we have nitrate versus nitrite, okay? And we'll see that nitrate has 3 oxygens and nitrite has 2 oxygens, right? Where the ite has 1 less than 8, yes? The 8 version has 1 less oxygen, yes? And we'll see that persists, right? So for example, chlorate and chlorite, right, differ by 1 oxygen. Ite has 1 less than 8. And we'll see that there's a hypochlorite. Hypo means, right, less than, right? From biology class, you should know that, right? So that has 1 less even than chlorite. And per, right, going back to like hyper, for example, right, has 1 more than chlorate, yes? So basically it's a naming system that allows you to commit more names to memory without having to actually memorize them because they're all related to one another, right? That's how it works for me, right? And so you need to understand that naming system because, for example, I could just as well ask you about a phosphite ion, and you should be able to figure out, oh, phosphite, if I know that phosphate is PO4, 3-, phosphite would be PO3, 3-, because it's 1 less oxygen, yes? So this is a basic set of polyatomic ions, and by extension, right, based on the naming system, right, you know a whole bunch of other polyatomic ions technically. Yeah, does that make sense? All right, thank you for listening. This is an introduction to naming of ionic compounds, and the next one is when we'll do our practice. All right, thanks for listening. Be good, and I'll see you soon. Bye.